So looking at page 45, we're talking about the Poisson probability distribution. This is the probability case that involves events happening over a period of time or a specific space. So some examples: number of cells in a specified volume of fluid, number of calls per hour to a helpline, number of emergency room beds filled per 24 hours. There's always a per, essentially. There are many types of Poisson distributions. It is dictated or predicated, I should say, on its or the rate, the average rate in which an event occurs. So we have the notation here. X represents the number of occurrences. Mu is the expected value. Right? We have the formula for the Poisson distribution. It's pretty funky looking. We'll get to that in a minute. Right? We also have expected value, which is equivalent to mu, and the variance, which is also equivalent to mu. Right? Fortunately, I mean, you could see that there's a lot of notes here, but fortunately, we're not really going to have to rely on the by hand approach because the calculator is going to handle that for us. All right. So I detail out a complete solution here, but I'll read it to you and then go through it. Suppose the average number of car accidents on a highway in one day, so that's 4, so that's 4 accidents per day. All right, so just going back to what we're saying here, expected number of occurrences, all right, that's what should happen. All right, X represents the number of occurrences on that continuous interval. Right, so we're going to let the mu value be equal to 4. Right, because that's the average number. That's what one would expect. So we want to know what the probability is of no car accident in a single day. Right, then what is the probability of one car accident in 2 days? Right, so we'll cross that bridge in a minute. But you can see, again, all this information here, useful, but if I want to know the probability that X is going to be equal to 0 using the Poisson distribution, I could follow this approach, or I could go into my toolbox under probability distributions, go to Poisson, right? And we use the Poisson PDF. All right, the M in this is the particular number of occurrences that you're looking to determine the probability of. So no cars, I would put that in as my M value. That's sort of the difference between the way NumWorks does and the way we do it. So 0, and then that lambda that they put in there, we use mu, they use lambda, that's going to be a 4. All right, so Poisson 0, 4, and you get the same value you would get if you did it out by hand. And these are very particular in terms of the types of questions that can be asked, so it's sort of nice, it's predictable. The other part of the question is if the number of, we'll call them successes, but that's pretty terrible in this context. Poisson, one accident in 2 days. So if it's 4 accidents each day, then it would be 8 accidents over the course of 2 days. So we're actually looking to do better than what the average is. Normally they say there's going to be 4 accidents over the course of 1 day. I'm saying I want to have 1 accident. Well, I don't want to have an accident at all, but maybe I'd be willing to accept 1 accident over the course of 2 days. And it still seems pretty bad when you say it that way. All right, so the Poisson PDF, I didn't put PDF in my notation here. I'll fix that real quick. PDF. All right, so you can recall or you just do it fresh. So 1, 8, and we're looking at the probability of that happening of being 0.00268. So actually my computation over here isn't as precise as I would like it to be. I'll just run it through the formula the one time so you could see. So e to the negative 8th, sorry, times 1 factorial is on the bottom, times 8 to the first power, so just times 8, over 1 factorial, which is 1. And you get the same decimal. This should have been a 3 if I was going to round it to that. That being said, I never should have rounded it that way to begin with. So that's a typo there. That should be 00268. All right. So fresh example here. Suppose average number of calls to 911 in 1 minute is 2. All right. So that's my mu is equal to 2. If you want to use lambda because they use it in the calculator, that's fine too. We want to know the probability of 10 calls in 5 minutes. All right. So this is for each minute. So mu would go, if we're going up to 5 minutes, we'd multiply that by 5. There should be 10 for each 10-minute period. So I want to know what the probability is of getting 10 calls in 5 minutes. Oh, I wrote 10-minute period. I meant 5-minute period. All right, so I'd use my Poisson PDF, number of quote-unquote successes, but again, it's not really a success if you have to call 911. All right, 10 calls, and that's going to be with the mu of 10, which is going to be about 0.125.